welcome to the first of the sessions for papers and talks. We have Christopher Jarvis giving a talk called The Devil's Calculator, Creating a Math Puzzle for Lovers of Logic.
Great, thank you. Should I go ahead and shut the door, or just leave it open for people who kind of...
Oh, wow.
It's pretty bad.
Okay, all right, great. Thank you so much.
Thank you.
Good morning. Thank you all so much for coming. My name is Christopher Jarvis, and I'm here today to talk about a video game, a math video game. The project is open source, nonprofit, and was recently named one of the 10 best indie games of the year by PAX. I don't know if any of you are big gamers, but PAX is the second largest video game competition conference in the world. We'll be there later this month, and we'll be the only educational game showcased there. So if you're in Seattle, please drop by and say hi. Our nonprofit has been making educational games for a few years now. Our first was a word game named Synonymy that we did in partnership with biologist and author Richard Dawkins. Our second was released during the 2016 election in collaboration with PolitiFact, the Pulitzer Prize-winning fact-checking organization. This game is a bit different. So first of all, you can download it by going to that link or by scanning the QR code there. Typically, once you're about a third of the way through the game, if you can make it that far, we ask that people donate $3 to our charity to continue playing. However, this code up here will allow you to unlock the game permanently, and it won't expire for 24 hours, and it can be used an unlimited number of times. So please feel free, that's an O, by the way, 4506, and then the 0 is with a line through it. So please feel free to share this with whomever you think may enjoy the game, friends, family. I'll also just add parenthetically that codes like these are available 24 hours a day, 7 days a week for educators and students at any level. Our nonprofit always makes our projects fully free to students and teachers. All right, so let's jump in. So the premise of the game is really very simple. We're all familiar with solving for x in an algebraic expression. So 5 equals x plus 3 would have x being equal to 2, obviously. This game, I suppose, is vaguely similar, but rather than solving for numerical constants, you're instead solving for the operators themselves. So for example, 4 equals 2 question mark 2. The operator could represent addition or multiplication or something else entirely, some other function or obscure operator that is highly unconventional. Perfect. Right. But something that is completely invented for the purposes of being, from obfuscating the correct answer. We really don't know until we collect more data points. And that really makes this, at its core, a game of interpolation. So the object of the game is to calculate the same integer every level. And I knew from the very beginning that I wanted to make a game where you have to calculate the same number over and over again. And the first number that came to mind, perhaps the most infamous number you could say, is 666. And that is why the game is called The Devil's Calculator. Usually, we have like a cute little animation when you open the game that explains a story where there's a young man going for a math test and his calculator is possessed and his typical arithmetic operators like addition and subtraction are replaced with alien symbols, like that diamond symbol right there. That diamond symbol, that is a unary function. That is to say, it takes in one input and returns one output. So let's play around with it a little bit and see if we can't figure out what's going on. So, 9 diamond is 13. Okay, 3 diamond is 7. 2 diamond, 6. So pretty obvious here. The unary function is adding 4 each time. So to calculate 666, we would subtract 4 from 666, giving us 662. Second level, let's keep trying. So 6 diamond is 600, that's different. 4 diamond is 400. Okay, we can reasonably infer here that we're multiplying by 100. So 6.66 diamond. Now, before you think to yourself, oh, this is so easy, let me assure you it is anything but. Our nonprofit is not known for making easy games. In fact, at E3 a few years ago, when we had Synonymy there, a gentleman was waiting in line to play Synonymy on the show floor. And I asked him, how did you hear about this game? And he said, oh, I'm a masochist, and my friend told me I'd really like this. And I still don't know if he was kidding or not, but we'll say he was. So level 4, let's see if anything's different. So 6 diamond is 18. Okay, maybe it's adding 12. All right, we'll see. 2 diamond is 10. That's out. 5 diamond, 7 diamond, 20. Okay. Well, let's graph it. Maybe it's something non-algebraic. Well, it is fully linear, so we know that there is some algebraic property to it, maybe in the form of mx plus b. And in fact, it is in the form of mx plus b. It's 2x plus 6. So 666 minus 6 divided by 2 would be 330. Now, on this next level, something is a little different. One of the keys is on fire. Let's see if that goes anywhere. 9 diamond, 3 diamond is 14. Okay. 8 diamond, 19. Okay, so we're adding 11 each time. Great. So 666 minus 11 is, that's not good, 655. So we're kind of stuck. We have no other operators. We have to calculate 666. And this kind of introduces one of the first of several escalating mechanics in the game, recursion. So what we'll need to do is we'll actually need to use the diamond function twice in succession. So 11, if we add 11 twice, we could just add 11 twice to 644. And then the diamond acts on the 644, then the outer diamond acts on the result of the first function, which should give us 666. However, this can get very complicated. I'm sorry? Because if you click a button that has fire on a level, it's not, you can't use that numeral in that level. I'm sorry I didn't make that clear. Yes. If the button is on fire, it cannot be used, which makes things awfully difficult. So in this particular level, I will give you a hint. It's the exact same function that we saw earlier, 2x plus 6. But our last solution, 330, obviously will not work because we can't use a 0 or a 1. So in this recursion, we would have to say, okay, 2x plus 6 equals 666. Obviously 330 doesn't work, so let's plug in 2x plus 6 again. This would resolve to 4x plus 18 equals 666. Now, by the way, I don't expect anyone to be able to do all of this in your head, or we have sophisticated tools within the game, access to Wolfram Cloud APIs, Wolfram Alpha calculators, all of that stuff. Wolfram is actually in part sponsoring the game, and that is very much encouraged. It's more about the puzzle solving and trying to decipher the logic behind the answers. But in this example, 4x plus 18, x would be 162. Oh, no, we can't do that either. So we'll have to go one rung lower. 2x plus 6, do the algebra, that ends up being 8x plus 42, which makes x equal to 78. And lo and behold, with 3 recursions, we get it. All right. So I mentioned earlier that the diamond is a unary function. There are lots of other operators in the game. So in here we can see a binary function, our pitchfork. This takes in 2 inputs and provides us 1 output. Same idea. So 9 pitchfork 3 returns 6. Okay. 5 pitchfork 5 returns 5. Okay. 5 pitchfork or 7 pitchfork 9 returns 8. Maybe some of you are starting to see it. 42 pitchfork 50 46. What it's doing is it's taking the mean. It's taking the average of the 2 inputs. So in this particular case, we can't use 6. So we'll have to come up with 2 inputs that average to 666. Let's say 777 and 555. So you'll notice that you don't currently have access to the diamond function. That's deliberate. We want to get the players used to and accustomed to the new operators as they come. But you are expected ultimately to be able to use both, and both in tandem. Once you use one lights up, both need to light up in order for you to beat the level. And in this particular level, you see that we have access to both operators. Let me pause here just for a moment to kind of briefly explain, the idea behind this game and where it came from. So I was really getting into machine learning. I was on Kaggle a lot, which for those of you who don't know is a machine learning website. It's really cool. It's like a bounty board. You go with teams and you do all sorts of machine learning problems. And very, very simply, not to get into any detail, machine learning is essentially multivariate interpolation. That is to say, you're taking data, you're looking at patterns, you're recognizing patterns, and you're trying to find a formula that fits to that data as closely as possible. And that, I think you might imagine how that was the basis for this, gathering data, looking at that data, analyzing it, and trying to work backwards to figure out the mechanics of how these functions really work. That said, the game also supports all sorts of advanced things, like if you want to export to Weka or you want to export to CSV with a full list of all of your data, you can do that. You can do all sorts of advanced analysis, logarithmic regressions in Excel, whatever you like, but you don't actually have to, at least for the base game. So when we have 2 operators in tandem like this, order of operations becomes extremely important. So 9 diamond pitchfork 8 is way different than 9 pitchfork 8 diamond. And as you can see, it adds parentheses. So in this particular expression, the 9 and the 8 are entering the binary function, and then the result is being acted on by the diamond function. So in this particular level, let's say 9 diamond is 900, 8 diamond, 800. So multiplying by 100, very familiar. Let's see about the pitchfork. 8 pitchfork 9 is, 0.8 repeating. 8 pitchfork 8. 1, it's division. There are 2 ways I guess we could work backwards. We could try to arrive at 666 using the binary function last, using the division last, or we could try to feed into the diamond function what we know would yield 666, which in this case is 6.66. The easiest would be 666 divided by 100. We can't do that. So let's do something like 333 divided by 50. Easy. So there is another operator yet to be unlocked. I won't spoil it for you. It gets a lot harder. We keep anonymous data on the game. To date, there have been about 25,000 people, close to 30,000 who've downloaded and played the game. Less than 400 have actually beaten it. So it is quite difficult. But even if you are able to get through the 70 base levels, that only scratches the surface. So what I'm most proud of with this game is that it has a full sandbox level editor. So you can create your own levels and share them with the community. And we also, in addition, have a DLC section, which allows us to showcase our favorite levels, many of which are written by very famous mathematicians. So Alex Bellows, who, if you don't know who he is, he's really cool. He's a best-selling author. I love his books, particularly Here's Looking at Euclid. And he writes for the puzzle blog for The Guardian. And this is his level. And we can play around with that, kind of see how that looks. Oh, I should note that once you beat the main game, the base game, you unlock the ability to make levels and play levels that don't have to equal 666. So in this case, the object of the game, the object of this particular level is to calculate 10, as you can see up there next to that asterisk. So Alex wants us to calculate 10. So let's do our tried and true. All right, 8 diamond is 1. 7 diamond is 1. 2 diamond is 1. Okay, 0 diamond is... Okay, 55 diamond is 1. Okay, 9 diamond. 9 diamond is 2. Okay. What should we try next? All right, 56. 56 diamond is 2. Okay. 41 diamond. Anybody else want to try something? 124. 3. All right. Who has an idea of what's going on here? Exactly. The number of distinct digits. It is returning the number of distinct digits. And the goal and the objective of the level is to calculate 10. So I think I see where he's going with this. He wants us to deal with pan-digital numbers. Pan-digital numbers are numbers that have all of the digits 0 through 9 in them. So somehow, because the 3 is on fire, we can't actually input a pan-digital number ourselves. The closest we can get to is 9. So 1, 0, 5, 4, 2, 6, 9, 8, 7 should yield 9. So somehow we're going to need to exploit this binary function here in order to calculate a pan-digital number. So let's see what it does. 6 pitchfork 5, 90. 1 pitchfork 2 is 6. 4 pitchfork 5 is 60. Okay. 9 pitchfork 2 is 54. So it seems like what's happening here is that we're multiplying the 2 inputs and then multiplying 3 on top of it. So from here, it seems that we have to calculate a pan-digital number using 2 inputs and then multiplying them together with a 3. And some of you may know that pan-digital numbers are always divisible by 9, and 9 is divisible by 3. So I think that will be a good hint, a good jumping off point for this level. So yeah, I think that's pretty much my time. I really deeply appreciate you guys coming here. If you like the game, if you like what we're doing, please download the game, leave a review, share it with friends and family, and thank you so much for coming. Thank you.
So questions? Oh, come on, you just got.
Come on. I'm sorry? Yes. So the game is available on iOS, Android, Windows Phone, Kindle, Amazon Fire, and Steam. So it is primarily consumed on phones as an app, but some people prefer to play it on Steam, which is desktop, like Mac, PC, Linux, something like that. Great question. I'm sorry I didn't make that clear.
Okay, how many of us are going to waste how much time? And then, well, no, not waste.
You know, I will say that in addition to one of the metrics that we do track with the anonymous data is how much time people spend. They average about 9 hours playing the base game. So, yeah.
Any other questions?
On which time of day? No, we don't track that, unfortunately.
Oh,
That would be interesting to see, though. Yes.
So the functions are always with full operators.
The functions are what?
Always making use of full operators.
There are 3 different operators. I went through.
So what I meant is like always.
Oh no. It gets absolutely evil. There's one that sums all of the prime numbers between its inputs. Like it gets really, really obscure and makes you work for it. Yes. I'm sorry? What do you mean by a one-way function? Oh yeah, you absolutely can, and many of the functions in the game are non-invertible. Yeah, when you're making your own levels, you can kind of see the breadth of what's possible here. So the DLC levels create. You can basically write your own code with. There's an open source awesome math repository called Math.js, which allows for complex numbers, allows for all sorts of really cool expressions. And it natively supports that. So just write your Math.js expression. It supports ternary operators, so like you can do something different if the input is even versus if it's odd, like weird stuff like that. So you can really go crazy. So you know what? No. One of my friends, when I first showed him the game, was like, teachers are never gonna like play this in their classrooms. I was like, oh my god, I didn't even think of that. But no, to date, no one has expressed any kind of issue with it. I think partially because we hedge that with the kind of cutesy animation in the beginning, where we present it like it's a very kind of innocuous little cute thing. So yeah, so far no.
If say teacher use that in your class and have requests, they have questions.
Absolutely. We have a lot of teachers who use it in their classrooms at a lot of different ages. And yeah, I can absolutely get them codes for all of their kids and facilitate all of that. So in addition, you can make custom levels yourself as a teacher for the kids.
Can people submit those custom levels to you all and have a playground where you can play
Absolutely.
other people's super evil?
So that all of that doesn't even require my moderation. It's all automatic. The game itself checks to make sure that your created level actually works and is fair. But optionally, if you're a little bit insecure with Math.js and programming the level yourself, you can always shoot me an email. We can build it for you. So.
Any other questions?
Great. Thank you so much.